find a change function. And the change function has to be derived from the original function, and that's kind of where the idea of calling this a derivative function comes from. A derivative function. And the main difference, derivative function, between what we're going to do now and what we did in the last few examples yesterday and today is instead of picking a particular number like 10,000 or back here where I picked the number 2, we're just going to leave that as an x instead. So the complicated part there is instead of having just one variable to deal with h, now we're going to have x and h to play with at the same time. So the general derivative function, the abbreviation is if the original function was called f, the derivative function is called f prime. So it's got this little apostrophe up there. And so we read that as f prime of x. And it's found by taking the limit, a couple versions of it, as, oops, not x, I want this version, as h goes to 0 of f of x plus h minus f of x all over h. So that's one version of it. The other version of it, and I'm going to call it same idea, it's the limit as x approaches a of f of x minus f of a all divided by x minus a. So that's another version of it. Now, since x is going to a, we'll end up with f prime of a here. No big deal. A is just some other letter interchangeable with x. But technically it's right, a different x value, but it's still an x value. So there's two different versions of this. This one is kind of the more traditional one. The blue one I call the alternative approach. And sometimes one is easier than the other. Sometimes they're both just a heck of a lot of work. So let's go for it. Let's just jump right into fun and games here. Let's let f of x equal, let's see, I want to go hard, but not too hard. How about 2x squared minus 3x plus 7. And I'm going to use the traditional approach on this one, which means to find f prime of x, I'm going to take the limit as h goes to 0 of f of x plus h minus f of x over h. And if you look at some of the examples in the book, they plug this in all at once. And so I'm going to write that down, but then I'm going to break it down. So if we tried to do this in one beastly step here, we would get 2 times x plus h squared minus 3 times x plus h plus 7. All right, so that's that guy. Then we would have to subtract from that parentheses the original 2x squared minus 3x plus 7, and divide all of that by h. And then clean this numerator up, divide by h, and pray you can take the limit. Alternatively, I like to kind of break it down and do a few steps at a time. So you can continue writing that down and solving it that way if you want, but I'm just going to do that. Then after I clean that up, I'm going to do the subtraction. And then after I get that subtraction cleaned up, I'm going to divide by h. And once I do that, it should be relatively easy to just apply the limit. So that's going to be step 4 there. All right, so step 1 for me is what is f of x plus h? And my way of doing that so I don't mess it up is f of parentheses equals 2 parentheses squared minus 3 parentheses plus 7. And then I go back and I pop in that x plus h. I make less mistakes when I slow down and do it this way. Remember, squaring something, there's no shortcut. You have to multiply this by itself. So that right there is x plus h times x plus h. And then we don't want to forget to multiply that 2 back in. So this right here is going to give me, what, x squared, and then there's going to be an xh and another xh, so 2 xh's plus h squared. And I don't want to forget to double that. And then we might as well do this distribution here, so minus 3x minus 3h, and then plus 7. All right, so cleaning this up further, we get to distribute the 2 through there, so 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 7. Are there any like terms in there? That's the only x squared. I got all the xh's, h squared x, just h, no like terms. So now I'm ready for step 2. So step 2 is where we, from that, subtract f of x. And to do that, I'm just going to stack it underneath here. So I'm going to subtract that 2x squared. Then I have to subtract negative 3x, which is really a plus 3x. And then I get to subtract the 7 and then see what's left. So that's gone, that's gone, that's gone. So polynomials are pretty nice. Things just kind of disappear after we expand. So we get 4xh plus 2h squared minus 3h. But that was not a very good h. There we go. All right, so ready for step 3, where we get to divide by h there. All right, so new page. So now I'm at stage 3, which is to do the whole quotient. So that means I've got my 4xh and then plus 2h squared. What was the other one? Minus 3h. And I get to divide all that by h. Now, fortunately, all of these terms have an h in it, so I could factor the h out. So I'm going to do that next. So the numerator can be viewed as h times 4x plus 2h minus 3. And then we divide the h, right, this guy right there. And fortunately, a number divided by itself is 1. And 1 times anything is itself, so I'm left with just this right here. And I'm ready to take the limit. So finally, step 4, I've got the limit. So I want to know what is the limit as h goes to 0 of 4x plus 2h minus 3. And the 4x has no h in it, so it doesn't care what the heck h is doing there, so I'm just going to have a 4x. Well, 2 times h is getting smaller and smaller. 2 times a small number is still a small number, so that whole thing is going to 0 right there. Let's use a different color. So in the limit, this part right there is going to 0. And 3 is just 3. It's just hanging out saying, hey, I'm just 3, take me away. I want that to be green. There we go. Okay, so what do we have here? This right here is called the derivative. This is what we call f prime of x. So I like to call this also the slope function. So at any point on the curve, if we want to know what the slope is there, we just say, hey, plug in the x value. This tells us the slope. So let's check this graphically to make sure that it works. And I think I need a new graph. Just start a new GeoGebra up. All right, so original function, f of x equals 2x raised to the second minus 3x plus 7. So there's my original function there, right? I think I wrote that correctly. Check. There you are, 2x squared minus 3x plus 7. Okay. So I can drag this down to see it a little better. So it kindly graphed the x-intercept there for me, which is the 0.07, right? We can see that there. We could check, hey, what's the tangent look like? What's the slope there? Now we have this slope function. I'm gonna call the slope function, how about, I don't know, let's call it d for derivative, d of x. And we calculated that to be 4x minus 3. Now, that's not a tangent line. Clearly, it doesn't even touch the curve. But what this tells us is that anywhere on this green curve, if I want to know what's the slope at a point, go ask the blue curve. Okay, so I'm going to ask the blue curve. So I'm interested in the point, and I'll graph it, the point 0, comma f of 0. So this point right here, I want to know what the slope is. So to get the slope there, I just say, hey, derivative function, what's the slope there? So I just say, what is d of 0? And the computer says, hey, the slope at that point ought to be -3. All right, let's check. Tangent line, remember I said use the point slope formula. So my point is 0, 7, and my slope m is -3. So kind of cool, that is the y-intercept, right? And this is the slope. So the tangent line there should simply be just y equals -3. X plus 7, boom. That looks like a tangent line, okay? So what I'm trying to do is I'm just trying to confirm, is this crazy function we just calculated, and that was a crazy calculation, does it really tell me the slope of the original function at any point? Okay? So another interesting thing we should note here in GeoGebraGraph is, let's turn that off for a minute. If I'm at the very bottom here, the very bottom, so let's see, that's going to be what? I have to calculate that. X is -3/4 there. So that point should be, no, +3/4, 3/4, comma, f of 3/4. So there's that bottom point. What's the slope at the bottom? Anybody want to guess at that? If I calculated that right, I think I did. That looks like it's at the bottom, yeah. What's the slope there at the bottom? So I'm walking along here, I'm going downhill, 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 downhill. I hit the bottom, then I'm going uphill, uphill, uphill. Evan says 0. Yeah, the slope is negative. I'm going downhill for a while. Then all of a sudden I'm going uphill. That's a positive slope. So if I go from negative to positive, intermediate value theorem says 0's got to be in the middle. So there should be a 0 slope there. And if we check with our derivative function there, what is the derivative, the slope, when x equals 3/4, it says the slope is 0. So I'm just kind of checking out, do I have the right rate of change function? And I do, it looks like I do. Cool. All right, next.